and welcome back. The Atmega microcontroller, as we have already seen, contains three types of memory. There's flash, where the sketch is stored, SRAM, where temporary data are stored, and EEPROM. SRAM, or static RAM, can store data for as long as power is provided. Turn off the power and everything in the SRAM is lost. Both flash and EEPROM memories persist after the power is cut, so you could use either one for long-term data storage, a bit like a hard disk works. But there's a difference. Flash memory can only be changed when a new program is uploaded to the Arduino. People often refer to this process as flashing. Once flashing is complete and the newly uploaded sketch is in place, you cannot change anything in the flash memory. That's where EEPROM comes in. EEPROM stands for Electrically Erasable Programmable Read-Only Memory, and you can use it to store data that must be preserved even after power is lost. You could use EEPROM to store configuration values for your sketch that the user can modify, passwords, sensor logs, and things of that sort. In this lecture, you will learn how to use internal and external EEPROM. The Atmega 328 contains 1 kilobyte of internal EEPROM. That means that you can store and persist 1024 words, where each word is made up of 8 bits in your Arduino Uno. For this demo, we will not use any external hardware, just plug your Arduino to your computer and you're good to go. In this first demo, we'll use two sketches to write and read a pin number for a basic security system. The writing sketch will write the default pin in a specific internal EEPROM memory location, and the reading sketch will simply go to that location and read the pin back. Keeping things simple, we are not going to worry about LCD screens, a keypad for the pin entry, or encryption for storing the pin securely. The pin we'll write and read is an integer. On the Atmega, integers consume 2 bytes, and we need to take this into account in our sketch since EEPROMs are byte addressable. This means that each byte has its own address, and we can't simply store an integer like we do with the RAM, where the compiler knows how to deal with the integer and other data type addressing. With the EEPROM, while using the basic facilities that come with the IDE, we have to split an integer to 2 bytes, store each byte individually, and then again separately retrieve the 2 bytes and concatenate them so that we end up with the original integer. Bear with me for now. In Demo 2 we'll simplify this process a lot. If the pin we selected is 1234, then converted in binary format, it would look like this. The byte on the right side is the low byte, and the byte on the left side is the high byte. We need to store each one individually, so we call EEPROM write twice. One for the high byte and one for the low byte. Now that the pin is stored in the internal EEPROM in 2 separate bytes, how do we go about extracting it? Fetching the 2 bytes from the EEPROM is straightforward. We use EEPROM.read, pass the address of the byte we want to fetch, and store what is retrieved in a variable in RAM. But how do we reassemble the pin correctly? For that, we use a bit shift left operator. There is also bit shift right. For example, take the A high byte and bit shift it to the left by 8 bits. Notice how all this operator did was to add the 8 zeros to the right side of the byte and push everything else to the left. We now have a binary number with 16 bits. That's 8 of the original bits plus 8 zeros. To the shifted by 8 bits A high byte, we just binary add the A low byte. And that gives us the original integer that we stored in the EEPROM, 1234. In this demo, we'll have a look at how to use the internal EEPROM in the AppMega 328. Now, the AppMega 328 has 1023 bytes of internal EEPROM, and in this demo, I'm going to show you how to read and write. To do that, I've created two scripts. One is a writer script. We'll use it first to write an integer into the EEPROM, and then we've got the reader script. We'll use that to read the same integer out of the EEPROM. I'll start with the writer script. So first I've got the inclusion of the EEPROM library. Then in the second line I've got the setup of my address, the first address. Just saying 0 here, that's arbitrary, but I could have used any byte address from 0 to 1023, which is the capacity of the AppMega. We'll see later in the external EEPROM example where we'll be able to choose as an address 1 out of 256,000 bytes. Now in the setup, I set the a variable to hold the byte, the integer, which is composed of 2 bytes. So it's an integer that I'm going to store. It's 1, 2, 3, 4. And this is where the actual writing happens. Now I say EEPROM.write, and I pass the address, and this thing called high bytes, a function, high byte, and I pass the integer variable. So what high byte does is to take my integer and then split it in its 2 parts. It will throw away the low byte, which I'm going to grab later, and just return the high byte. So I'm going to take just 1 out of the 2 bytes that make up the integer and store it at address 0. Then I'm doing the same thing, but now I increment my address by 1. So now I'm going to write the next byte in EEPROM address 1, and I'm going to now ask for the low byte to be returned from my original integer. So I pass the integer, I get back the low byte, and then I store the low byte of my original integer to address 1. That's about it. Once these 2 functions have executed, my integer in its 2 parts has now been stored in the EEPROM permanently. So even if I cut off power and then restore the power, that information will still be there. There's some printouts then happening, and the loop is empty. Now let's have a look at how to extract that information from the EEPROM. So let's go to the reader sketch. Again, we start by including the library. I set the byte address of the first byte of the integer, and then the setup, I set up my 2 variables, one for the high byte and one for the low byte. Now to get the high byte, I know by design, because I created the writer script, that the high byte is stored at address 0. So just go and say EEPROM.read 0, and whatever byte comes from this is going to be stored in retrieve high pin. Just the name that I chose. I do the same thing for the second byte. I know from design, because I created the writer sketch, that the low byte is stored in address 1. So I'm going to go and grab address 1, grab the byte in address 1, and store it in retrieve pin low. So just for good measure, I'll print those 2 out in this serial monitor, and then the assembly of these 2 bytes back to the original integer happens here. So here is a shift left by 8 bits for the high byte, and then just add that, it's a binary addition, add that to the low byte, and I'm done. This way I have now retrieved my original integer in its 2 byte split in 2 bytes back to the original number 1, 2, 3, 4. Let's upload that, make sure it works. So start with the writer sketch. Okay. So my pen recorded 1234. So the value 1234 is now already stored in the EEPROM. Let's go and upload the reader sketch. Okay, done uploading. Retrieve it. There you go. So this is the first of the 2 bytes that make up the original number. Here's the second one. Then I stick the binary representations together, and I end up with the original integer that I stored, 1234.